recent fossil discoveries in Mississippi. And when you take a look at my opening slide, you're asking yourself, are these really recent fossil discoveries? Have these been found in Mississippi? And if you're not asking that question, I know these guys over here are, because they have no idea what I prepared for today. So did I find a cow fossil in Mississippi? I certainly found recent cow bones, but no, I haven't. This is actually a little exercise I sometimes like to start with to test your knowledge. So one of my colleagues over here is going to hand out a pop quiz, and we're going to give you 5 minutes. No, I'm just kidding. I like to intimidate people. No, we're just going to review some slides, and I usually do this if I think there's going to be a large number of younger participants in the audience, and we have some young people out there. Are you young? All right, I'm in the young club. So I'm going to ask, because it's usually them that provide all the answers. As adults, we've been exposed to a lot of this when we were younger over the years, but we've forgotten it all, right? Heck, I've forgotten most of it. But I'm going to test your knowledge here with some of these figures in my slide and ask you a few things about some of these objects and see if you know what they are. Like this object, this round object with these little circular puzzle pieces over the surface. Does anybody who doesn't know the answer have a guess as to what this is? What sort of, pardon?
Sea urchin?
It is. It's definitely a sea urchin. Well, it's missing some parts. What parts is it missing? The spines. And so we got to put some spines on that. And now we perhaps better recognize what this actually is. So this is an example of, this is a decent example of what we have to deal with in the fossil record. We're usually finding incomplete objects, in fact, just fragmentary objects as paleontologists, as collectors, as whether we're novice or professional alike, we're all dealing with the same materials, and it takes quite an education to understand what parts of the bodies represent. And what I mean by take a bit of education is just repeated exposure to. That's all it is. It doesn't take, a college education to at least recognize these objects. Although to understand more about them outside of that, it does. But nevertheless, to recognize these things based upon fragments, and typically we just see pieces of the urchins, just this part, and we almost never see something that is as complete as this, with the spines. We occasionally find different types of urchins with tiny spines adhering to their tests or shells, but never one of these with the great big spines. And so some of these range in the size. 5 centimeters may not be relatable to a lot of people, but these little urchins can be about this size, or they can be that size with the spines. Let's take a look at some of these other objects here. Let's look at this representation right here of an animal. We've got an artist's interpretation of it, and then we have a picture of the head and the neck, a close-up of the skeletal reconstruction. Does anybody want to take a guess as to what this is? What type of animal is it? Is it a cow or an ant or a pickle? Is it a mammal, a bird, or a dinosaur, or a turtle? You want to just A through D, try to guess which one do you think it is? Does anybody want to take a guess? We'll open it up to the floor. Yes, ma'am. It is a dinosaur. It very is. So it's in a group of dinosaurs called the Oviraptorids. So, I'm sorry, Dilophosaurids. What am I saying? Oviraptorids have a similar thing on top of their head, but this one is Dilophosaurus, and it's a type of theropod dinosaur. And theropods, although they did give rise to birds, to modern birds, to all birds, this one did not. It's in a different group of theropod dinosaurs. So yeah, that's what we've got there. And they also had feathers. They were very fine feathered. The dinosaurs had various types, at least the theropod dinosaurs. Jill, let me know if I'm too close to the microphone.
You're good.
Okay, all right. So dinosaurs had different degrees of development of pelage or the feathers that covered their body. Some of them could be fine, some of them could be coarse or big, and it was often a mixture of those. Now, what sort of animal is this?
Where in Mississippi was that?
Oh, none of these are from Mississippi. This is just a lesson in what is that object. Yeah. None of these are so these opening slides, none of these are necessarily from Mississippi. This is just a little game or exercise to test knowledge and introduce you to some of these objects for which we have similar things in Mississippi. We do have dinosaur fossils in Mississippi, but no Dilophosaurus. So what sort of critter is this? Do we want to, is it a dinosaur? Is it a mammal? Is it something else that I haven't listed? You, sir? Oh, did you say it was a Rawasuchian? Well, you're absolutely right. Very good. You are absolutely right. In fact, I'm sorry, it's actually an Aedosaur, but that's okay. Sometimes we get things wrong. I remembered it as a Rawasuchian, but there's these Triassic age, these reptiles that are over 200 million years old that look very similar to one another. Some of them are crocodilian-like. Some of them are unlike anything else that succeeded them thereafter in other parts of the Mesozoic. Certainly nothing like that we have today. But this is Desmatasuchus, and it sort of resembles some of the armored dinosaurs that we had much later in time. But it's actually a type of Triassic reptile called an Aedosaur, and we don't have any record for those in Mississippi. So of these objects, let's do this one. This one might be familiar to some of you. What is this? Anybody want to take a guess? Yes, first of all, is it a plant or an animal? It looks tree-like, and I'm glad you used that as a guess. So is it a plant? Is it an animal? Yes, sir. Oh, you're closer. So it is not, in fact, a plant of any sort, but it looks plant-like. In fact, it has a plant-like name. It's called a seabud, which makes you think of a plant. There are other members of this group of animals called echinoderms that have plant-like names, like sea cucumbers. So these guys, these seabuds, are not plants. They look like a plant. They look like an inflorescence. And there are also things like crinoids or sea lilies, sea cucumbers. Sand dollars are members of this group of echinoderms. They call them spiny-skinned animals because they have a hard exoskeleton that's sort of spiny. But the sea buds are actually a type of animal, and that thing that looks like a flower at the top, as in crinoids, is actually their feeding organ, feeding and breathing. It's a cross-section of what one looks like. And these are attached to the seafloor, but they're not permanently attached to the seafloor. So if a strong current comes along, they can be uprooted, and their roots, called the holdfast, although it can hold them to the floor, a current can uproot them, and then they can reroot themselves. They can manipulate their roots, unlike a plant can. So a type of animal. All right, the last one. What did I say? I would save the best for last, right? What is that? A cow, are you sure? Are you absolutely sure? What sort of animal is it? Mammal, it is. Say it with certainty. That's a mammal. It isn't, are you sure? Are you sure? It is indeed a mammal. So let's get on with the rest. Enough silly business here. Let's talk about the recent fossil discoveries in Mississippi. Now this is a map that's a variation on our traditional geologic map, which I like to put up there, but this is really much more basic than that. And it separates, using colors, Mississippi into different time periods, so the parts of Mississippi that are attributable to different time periods. And I'm going to say this is what we call shallow Mississippi. This is what's called the shallow subsurface. Know that if you go deeper, there's even older and older and older stuff. So this is the geology of Mississippi, at least what it looks like, represented into these different time periods in the shallow subsurface, that is just below the soil. But if you peel it back even deeper, you get into totally different types of rocks. But this is the shallow geology of Mississippi. And this is what we're interested in. Most of us are interested in, certainly what most paleontologists are interested in, because this is the most accessible. Otherwise, you'd have to use a drill or a coring device that goes really deep to see the much older stuff that is inaccessible. But the shallow subsurface exposures go back some almost 400 million, about 400 million years. But today's slideshow is going to focus on the last 90 million years because we haven't made too many recent fossil discoveries that are really old. In fact, the oldest parts of Mississippi, can everybody see my arrow? Does that show up? My cursor doesn't show up on the screen?
I don't see it.
Well, because it's probably just white, it's a white slide.
Oh, okay. But the oldest rocks in Mississippi are in the upper right-hand corner. Right up here. And it may be hard to see, but those rocks are blue. The colors up there are blue that represent those oldest rocks. And they go back sometime between 330 and 400 million years ago. But we're going to stick with the rest of the map, basically from the green into brown and the yellow and the red and into some of the other colors here. So the young stuff, the stuff that's less than 90 million years old, that's pretty young, right? Geologically it is, of course. Now there's some other features on this map that you'll see around Jackson and in the South Delta. Can you read what they represent and look at the legend and tell what they represent? Is it explained in the legend? What do those structures look like in the South Delta? What are we trying to represent there?
Volcanoes.
Volcanoes, yeah, those are actually volcanoes. Those are extinct volcanoes that lie beneath the South Delta and adjoining Arkansas and Jackson. And there are some of about the same age off the coast of New Orleans, within 40 miles offshore. So these volcanoes date to the Cretaceous period. And although inactive, they were very active during the Cretaceous period, beginning about 95 million years ago. And we have ash deposits in the city of Aberdeen, Mississippi, that testify to some of the volcanism that occurred on the North American continent, in that case, 85 million years ago. Now the Aberdeen ash deposits, if you've ever heard about them, you would have, you know them as the bentonite mines, if you know these mines at all, where these ash deposits are preserved. I'm sure Brad has heard about them, the bentonite mines. These are altered ash deposits. They are, according to the geologists that have studied them, they're not from the Jackson or South Delta volcanoes. They're from more northwesterly occurring volcanoes that were part of the early Rockies. We don't have any ash deposits at the surface or near the surface that we can associate with the West Central Mississippi volcanic province. But nevertheless, there's evidence of volcanism during this time period in Mississippi. How many of you knew about the Jackson volcano? Show of hands. Okay, great.
Does the number of volcanoes that are depicted on the picture indicate the specific number that we know of in Mississippi? I'm not
Yeah.
seeing five.
Basically, it does. There's been some argument about whether they were above the surface of the water or below the surface, whether they formed actual islands or whether or not they were just oozing beneath the sea level and formed. They definitely formed domes. We call this structure around Jackson, we call it the Jackson Dome. We call those in the South Delta, the cluster of two, we call it the Sharkey Platform. These are bulges in the crust. You probably heard of the salt domes in South Mississippi. Those are also bulges from rising salt. This is a different type of thing, but it's sort of a similar principle. You're getting, in this case with volcanism, you're getting magma from the outer part of the Earth's mantle that's rising to the surface. The general agreement, though, is that some of these, particularly the Jackson volcano, may have been an actual island arc system. But some of them are still speculated to be oozing beneath the seafloor and just making a dome-like thing. A oil company, I forget the name of them, maybe it'll come to me, produced an educational booklet to be able to better relate their oil exploration and their company. And they provided this to stockholders, just to the general public. And sometimes it's hard to relate the petroleum industry to the average public. In fact, there's so much of it I don't understand. You know, oil exploration, the jargon, for instance, and oil exploration, and some of the remote sensing they use to detect oil-rich layers down beneath the surface, how the oil pools, et cetera, et cetera, et cetera. I had a course on that, but I forget most of it. So when they found out in the early or mid 1980s that when the executives found out that there was a possible island arc system where dinosaurs might have lived during the Cretaceous period, they decided to seek out the expertise at the Mississippi Geological Survey. This is the Mississippi oil exploration folks, and asked them more about this. And eventually they started incorporating dinosaurs and paleontology into some of their advertising to make it worthy of, or at least appealing to public consumption. And eventually they had, I think it's around 2005, they produced this some kind of statistical booklet about their finances or oil exploration or whatever. And it was, they devoted plenty of pages to dinosaurs and the Jackson volcano and things like that. Made it very readable and very collectible. And I wanted a copy of it, but they were already all given away, and so I don't have a copy of that today. I'm sort of sore about it. But anyway, they had employed an artist who did some great illustrations for that volume. That to the rest of us, otherwise might have been sort of yawny, because it had lots of statistics in it. But nevertheless, the island arc system was present in west central Mississippi up until at least the Eocene epoch. We have evidence that it may have been bulging as recently as maybe 50 million to 45 million years ago. There may still have been a rise there. And the connection to oil is this dome had oil deposits around its periphery. And it became a significant oil trap. And that was the connection between the paleo and the geo side of it, oil exploration side of it. But yeah, volcanoes in Mississippi, again, all extinct. And ash deposits around Eocene. We've represented the ash deposits in that sort of a light blue color that passes through Aberdeen there in the northeastern part of the state. The geologic time chart is relatively incomplete in Mississippi. There's a lot of gaps in it. This particular chart goes back some, I can't even read the numbers there, some 4 billion years, 4.3, 4.5 billion years. We're only going to look at we only look at these particular intervals in our interpretive fossil wall in Jackson. And this is what we usually talk about in a program on the general geology and paleontology of the state, myself and the Office of Geology when we're doing outreach. But for the recent finds presentation today, we're going to focus on the last 90 million years. And the oldest fossils we'll discuss are those from the late Cretaceous period. In 2024, approximately 3,000 fossil rock, sediment, and mineral samples were cataloged at the Museum of Natural Science by me. And it was a chore. And there was a lot of cataloging. You guys donate way too much over there in the right-hand corner. See how much work you make? No, I'm just kidding. I love it. A lot of these samples are collected by myself and my volunteers, but we do get donations from the public. And it wasn't a peak year, but I'm kind of glad it was because I had a lot of other things to do. The fossils include mammals, dinosaurs, different types of reptiles related to lizards and snakes, bony fishes, sharks and rays, chimeras or ratfish, crustaceans. I mean, it just covers the gamut of marine organisms because we primarily have a marine fossil record in the state. That's true for the last 90 million years, and it's really true throughout the geologic record for Mississippi, whether it's shallow subsurface or deep subsurface. And we'll be talking about an exception to that in more recent geologic time. This presentation only discusses those found in the last couple of years, deemed interesting to most people and or photogenic. All fossils are not photogenic, and not all of them are that interesting to the public or relatable. Like one of my favorite things is bryozoans. How many of you know what a bryozoan is? They're really cool, but I'm not going to tell you about them today because they're only photogenic with electron microscope. And I do have a lot of those slides, but we'll save that for another time. But we're going to talk about the big things, mostly things with 4 legs, but I've included some non-legged animals in there too. And sadly, we're not covering the Paleozoic. A lot of folks love the Paleozoic. But one of our door prizes today, our competitive fossil prizes, that is, will already go to, again, for the second time running, fossil that walked in here earlier. Is she still here with the crinoid calyx? Okay. It's certainly the rarest fossil for Mississippi. And I was going to have to fill out 2 forms for the rarest fossil because then another one walked in. And we may give her the most exotic. She already won an award in a previous year, so maybe we'll just give her this year. But we can also do the most exotic because it is a fossil that doesn't exist in Mississippi. I mean, it could in the very northeastern corner of the state, but she found it in her backyard in New Albany, which was crazy, and it's beautiful. So we're going to start in the very northeastern corner of the state, and we're going to go through time, go into progressively younger deposits, which we will achieve by going either west or south through the younger deposits. The oldest deposits, again, are in the very northeastern corner of the state. When I said we're going to go from oldest to youngest, I take that back, because I see in the next slide, we're actually going to start with the youngest, and then we'll go back in time. Imagine me varying things up, making them exciting and unexpected. So unexpected, I didn't even know that's what we were going to do until I looked at the next slide. So let's start with the youngest fossils. And this youngest interval in time, the Pleistocene epoch, for which we have a really good fossil record in certain parts of the state, is actually non-marine. We don't, or largely non-marine. We do find a few marine fossils from this time interval, this very recent time interval, from about 100,000 years ago to about 11,000 years ago in coastal Mississippi. But most of our Ice Age fossils are coming from western Mississippi, northwestern Mississippi, and northeastern Mississippi, and some are coming from central Mississippi. And one of the big discoveries is this mammoth tusk from last fall. How many of you read about it in the social media? Have you heard about it? Okay, cool. Yeah, it was quite a discovery. I guess you shared it on the museum's website? Okay. Yeah, this was a fantastic discovery. Is very rare. No one has, to my knowledge, in either Alabama or Mississippi, outside of Florida at least, has recovered a complete mammoth tusk. We've found pieces of them before, but pieces of a mammoth tusk are not always diagnostic immediately. Sometimes microscopes can tell and distinguish between certain types of elephant-like creatures based upon looking at the fine structures in tusk. But for a whole tusk to be absolutely diagnostic by looking at it is unheard of, because you seldom find a whole tusk. And certainly this is the first whole mammoth tusk we've run across in the Twin States, that is Alabama and Mississippi. And the mammoth is easily distinguishable from mastodon tusks in that the mammoth tusks have tusks that first, as they exit the skull, they go down like this, and then they come back up in a loop, and then they curve inward. They curve, is that right? Curve inward? Now I forget. They curve outward. Anyway, they go down and they go up, whereas mastodon tusks, when they come out of their skulls, and mastodon remains are actually more abundant in Mississippi, they go a little bit down and then out, and then they curve in like this. So very different tusks, easily distinguishable from a whole specimen. Otherwise, you have to use a microscope to distinguish them. So it was a spectacular specimen. It was found by a civil engineer in Madison, Mississippi, in November of last year, and he called me. He says, "You need to help me come get this out of the ground." And I said, "What out of the ground?" Expecting something spectacular, especially from this guy. But I had no imagination that he was going to tell me a tusk. Sadly, I was on duty that day, so he called the Mississippi Office of Geology, and they sent 2 geologists out there to help him extract it. And it is
only
on,
one tusk?
pardon?
Was it only one tusk?
Correct, it was one tusk. And more often than not, in fact, 99% of the time, we just find a single fossil of something. We don't find articulated remains. That's a very rare event. See, these bones, these teeth, tusks, whatever, they're preserved in streams, alluvial systems, and they get scattered easily. They're seldom buried right away. And of course, we do have a few instances where they're buried relatively quickly. We have part of a mastodon on display at the museum called the Vicksburg Mastodon, or it was found beneath the Vicksburg Mall in the mid-1980s by my predecessor, the former paleontology curator there at the Museum of Natural Science. And it was found in a system where it was quickly buried, but it was quickly buried by wind-blown deposits, although we're not absolutely certain whether it was covered immediately by the wind-blown deposits or whether streams picked up the wind-blown deposits and then subsequently covered the mastodon. Anyway, you're going to have to get quick burial, and so seldom do you ever get quick burial of remains like this. We have other instances of quick burial in Ice Age deposits. This is just the Ice Age deposits. And generally those occur in oxbow lakes, where something sinks to the bottom of an oxbow lake. And if it's not predated too heavily, it may get buried right away. An example of that would be another partial mastodon, or the Demopolis mastodon in adjoining Alabama. That was buried in an oxbow lake. A lot of the stuff that's found in the Mississippi River, loose in the river, probably represents animals that may have been partially buried and their bones gradually released in the Mississippi River by the migrating Mississippi. The Mississippi is and was back then filled with oxbow lakes and their floodplains, and that's a quick way. And floods too would help bury more complete remains, preserve more complete remains. In this case, this was probably found in either a tributary, probably a tributary of the Mississippi River, and buried in a flood in the alluvial floodplain, or buried in another stream. So as streams migrate over time, they may quickly bury something or bury a part of something, and then that stream moves to another location, and then a stream down the road. Streams are constantly forming and moving and going extinct, and in this case, a stream also exposed it. And the black portion on the left, the lower part of the tusk, was what was exposed when the gentleman found this, Eddie Templeton, found this specimen, and he found these two horse jaws you see right here in the same general area. I don't know if it's the exact same area, it was the same general area. It's an area he hunts in Madison and Yazoo counties, Mississippi. This is a region called the Lurse Hills, and the Lurse Hills are rich in Ice Age fossils. People also refer to them as the Bluff Hills. You may know it as the Bluff Hills. Or the Loess Hills, Loess, L-O-E-S-S. You may have just read it and not be familiar with the pronunciation. There are different pronunciations of it. Who's heard of the Bluff Hills, the Lurse Hills? It's in Mississippi, it's the eastern margin of the Mississippi River floodplain. So it forms the eastern boundary of the delta. These two horse fossils represent different genders. And I couldn't believe it. This young lady wants wants herself to distinguish between she wants to tell you which one's male and which one's female.
Oh.
I assume that's where you're going with your question.
I was going to ask you how you know.
Oh, how I know, okay. I was hoping you would know.
Top one's
Let's speculate, go ahead.
I think the top one's the male.
Pardon?
Out of the two.
I'm hard of hearing.
The top one's the male.
What did she say?
The top one's a
Top is the
male?
male.
Okay, does everybody want to say the top one is the male? Does anybody else have any other ideas? Okay, I need one more person to come up with a suggestion. Any ideas? Blake, you're conferring with your brother?
He's got it.
You've got it. I'm sure you're right, Blake.
I would say the bottom's the male.
Absolutely. And I believe, they're not great pictures, but that side view, yeah, okay, that's what he's looking at. Notice the canine this, this tooth right here, that well-developed canine, so only male horse. If you've been around horses, who has horses? Oh, definitely don't answer now if you don't know the difference between the males and the females. Yeah, so males have well-developed canines. Sometimes the females can have canines too, but they're not well-developed. There is actually an alveolus or a socket, a very poorly developed socket on the female jaw. It's hard to see where there would have been a canine. And what's the other thing about the jaw? Notice the top view. So the absence of the canines. So without a canine, it's a female, but do you notice something else? And things are not always excellently preserved, and they're eroded, and sometimes you can't see these features or see them well. But you can see them reasonably well here. The female snout is narrower. And that was really cool. So obviously I begged Eddie to donate those too.
How tall is a Pleistocene horse?
Pleistocene horses were about the size of your average large modern breed of horse, not in other words, not a pony. So a thoroughbred, about the size of a thoroughbred. But there were smaller horses too that would be smaller, 13 hands high. There may have been as many as 3 Ice Age horses throughout Mississippi. Basically, 2 largish ones and then this smaller one. We do have an outlier that would have been, we got a fossil, single toe bone of a horse that would have been the size of a Clydesdale. But we call those outliers. If you don't find a lot of something, you're assuming that it's aberrant. It's not something that's typical. So I don't think there was a 4th species of giant Clydesdale-sized horse. We're just thinking it's a large variant. And it represents a big horse. But most of them are about the size of a thoroughbred. And the smaller horses tend to have been less common. And so yeah, it's that narrow jaw and the presence of the canine distinguishes it. Let's see. Mr. Templeton also donated these bones, and we got some publicity out of those. I think it was last summer. And I say publicity, the Mississippi Office of Geology has a wonderful social media department. And I want to say Jan's name, I forget her last name, but yeah. And she works with the geologists in the survey part of MDEQ. Ms. Jan and the geology guys at DEQ are really great about advertising fossil finds throughout the Mississippi. In fact, several of these have been on the DEQ social media page. Be sure to follow DEQ after you follow us at the Museum of Natural Science. But yeah, Eddie found these saber-toothed cat bones. And here's a saber-toothed cat, second metacarpal. Everybody hold up their hand. Hold up the hand. Your second metacarpal is basically this bone that supports your pointer finger. So it's this bone in the palm, and that's the equivalent bone in a saber-toothed cat or just in any mammal with 4 limbs. And that's a jaguar, the same bone in a female jaguar from the Jackson Zoo that my predecessor acquired in the 1980s when this old female died. I forget her name, she actually had a name, and we've recorded it in the database, but she was one of the much loved animals at the Jackson Zoo back in the 80s. And an even more recent donation to the Science Museum of Pleistocene Age is this radius bone. Everybody hold up their arm. And your radius is right here between your elbow and your wrist. That's your radius. So that's the radius bone of an American lion. And that's one of about 5 or 6 American lion bones we have at the museum now. These predator fossils, and I chose several of them because coincidentally we had several donations of these predators like the saber-toothed cat and the lion fossils. Again, isolated occurrences, but still very precious. Most fossils, as I said, are found as isolated occurrence, isolated bones, and often just fragments of bones. But the predators are very rare, so I like to showcase those. For every So basically, if you consider these carnivore fossils like the saber-toothed cat, the dire wolf, we'll show you one of those in just a few seconds, and the American lion, the predators are much rarer than their prey items, say the horses or the Pleistocene zebra, which is another type of horse, or any of the camels, saber-toothed cat, mammoths, mastodons. All these potential prey species of these giant Ice Age predators, they're much more abundant than the predators themselves. They typically, and by ratio, you may find a one carnivore bone for every 40 or 50, if you're lucky, bone of a potential predator, of a potential prey item. So the prey animals are much more abundant, simply because the prey species are much more abundant than the fewer species of carnivores, and especially with respect to the numerical ratio between the prey species and its predator species. And here's an example of a recent donation of a dire wolf jaw. It's just a portion of a jaw, but notice it compared to one of the largest domestic breeds of dogs that's around today. It's a Great Pyrenees, for comparison, at the top, and the fossil is at the bottom, of course. And notice the size of the molars. Not only is that section of jaw larger, but notice how much more massive the molars in the dire wolf are, particularly the carnassial tooth, which is the largest of those lower molars, but even the premolars, they're much more massive. And the depth of the jaw and the robustness of the jaw is greater, of course. But the dire wolf it's in the older literature, it's portrayed as being giant compared to the modern gray wolf. But there are two gray wolf species, the Yukon wolf and the northwestern wolf, the largest examples of which are about the size of a dire wolf. So they were not that much bigger, but they had much more massive shoulder, neck, and jaw musculature, and definitely more massive crushing teeth. It's thought that they filled in what we call an ecological niche or purpose in an ecosystem where they functioned as a hyena. Hyenas have very massive, robust, bone-crushing teeth. So some people argue that the dire wolf was primarily a scavenger. And if it wasn't a scavenger, if it packed like modern wolves, it may have completely reduced the animal in the pack all the way down to even the marrow. Whereas your American lion and your saber-toothed cat are probably not going to, they're going to leave those bones, those big bison bones, for the dire wolf to crush. Obviously the saber-toothed cat, their dentition is not modified for crushing bones. They have a very specialized dentition for stabbing animals and making them bleed traumatically. I've talked a lot about the four-legged animals. This is a really cool recent donation that has no legs, but a person with very capable legs today, Mr. Lee Davis, found this in a creek bed. And what I mean by very capable legs is that he was lame from hip surgery for 3 years and suffered terribly from not being able to find fossils. And this drove him nuts. It was almost 3 years. And one of his very first outings, he went with a friend. I think his wife probably insisted he be with a friend on his first outing after healing from his hip surgery. One of his first outings, he found this large concretionary mass, this large stone. It had impressions of these mussels in it. Now these are the original shell you see here in the upper right and on the left. These are original shells from modern streams in the Mississippi drainage, and they're called the three-ridge mussels. We find them today. They are extant. They are still living. But these fossil examples that Lee found are of Ice Age, and they are also found in the South Delta, in the Yazoo and Madison County areas, and they occur in these sandy lenses in gravel deposits just below the Ice Age loess. And they're pretty cool, and with Lee finding them and other people finding them, we think there is a whole bed of fossil mussels just beneath the Ice Age loess deposits in the Loess Hills. So we're thinking about putting a group together to go inspect these Loess Hill streams more for these mussels, because these are obviously of great interest to our malacologists, our freshwater malacologists who study modern mussels. Now on to the Oligocene. We're going to move from the Pleistocene, and the Pleistocene fossils can be found all over the state, but primarily they're most populous in western Mississippi and northeastern Mississippi. I don't have time to go into why that is the case. That's a lengthy explanation. You have to have special circumstances in your soil and in your alluvium to preserve these Ice Age fossils, these terrestrial animals. Now that we've moved to the Oligocene epoch, we're moving into marine deposits where we find marine animals. But I've started my first fossil from a marine sediment, and all the rest of these fossils are from marine sediments that I'll show throughout the slideshow. But I've selected a fossil that is non-marine because we occasionally find non-marine animals mixed in these marine deposits, particularly coastal marine deposits. These animals, they die in rivers or estuaries, four-legged terrestrial animals, and their bodies, their carcasses can end up in shallow marine deposits offshore or in estuaries. This bone right here is a rare discovery from Waynesboro, Mississippi, found in the Chickasahee River. It was found loose in the riverbed, and so we had to sort of backtrack with a little detective work to find out which unit it came from. And this came from a marine formation called the Payne's Hammock. And it's a series of bedded limestones and clays. And we occasionally find terrestrial animals like ancient rhinos and tapirs and a few other terrestrial animals in these marine deposits. And Lee found this tapir bone. Now, what is a tapir? Does anybody want to explain a tapir before I show you an artist's interpretation of one? That's okay. I mean, you can use your hands. I can't even draw with my hands. Oh, you're close. Yeah, you're close. So yeah, tapirs are still living today. We have 4 species living around the world today. Most of them are in Southeast Asia. One of them is in Southeast Asia, and the rest of them are in Central America. The black and white tapir, the Himalayan tapir, is in Southeast Asia, and the other 3 are in South America. They were much more widely distributed, going back in time. But they died out in North America at the end of the last ice age. These particular, this tapir bone though is from the Oligocene epoch, and this represents one of the earlier tapirs that's several tens of millions of years old. And this toe bone was found not far from the old boat landing there in Waynesboro, if you know the Chickasahee River. That was a really cool find. This gentleman right here who donated this fossil, did I get his name up there? Okay, I'm sorry. I didn't put his name up there. Does anybody remember his name? You guys don't know. Anyway, I wanted to honor, I like to honor all my donors, but I forgot to put his name on here. I'll give you his name in a minute. But he would not mind. He's such an easygoing guy. He paddles up and down the Chickasahee River, and he really knows the river well. He would not mind me telling you where his secret spot is, just below the boat landing. About 150 feet downstream. No, the water happened to be unusually low, and he found it loose in the river. He would not mind at all. Very cool guy. This is a recent species described in the literature. We've been finding these shark teeth for many years, going way back. In fact, I think Louis Agassiz, a Swiss paleontologist, Swiss naturalist, may have illustrated some of these teeth in some of his earlier publications from the 19th century. But they were only named up until recently by a colleague of mine at South Carolina State Museum. And so finally, this species, after all these years, has a name, Hemipristis intermedia. And this is an example of some of the teeth. This is an example of the size these guys attained. The largest of these snaggletooth sharks, as they're called, existed during the late Miocene and Pliocene epochs, much younger than the Oligocene. They were smaller during the Oligocene, and we still have Hemipristis living today, represented in that silhouette in the upper right, just downstream from that guy swimming. That's a modern snaggletooth shark. But they got very big after the Oligocene epoch, as you can tell from the larger shark there. Here's some of the teeth that were illustrated in the manuscript showing the different positions. Like a lot of shark teeth, we can tell the position of the tooth in the mouth based upon the shape of the crown, which way the tip leans. So I'll ask you, if a tip is, if you think of a shark like our mouths, and we call this the symphysis, sort of a suture there where the two jaws come together, upper and lower jaws. Sharks had a similar construction. So the teeth are what we call recurved. So that means the point of the tooth, the apex of the tooth, is pointing towards the back of the mouth or the sides of the mouth. So back or sides, or the front of the mouth. Are they facing back or are they facing forward? Correct. So they're recurves, they curve towards the back. Or you can say from the middle towards the sides, either way. So they recurve towards the back. And that recurving helps the shark keep the animal, the prey item, in the mouth. It's the way it gets trapped in the mouth. And so this is a selection of teeth from the Waynesboro site. These are also from Waynesboro, the ones on the right. The other teeth are from near Brandon, Mississippi, from the old Marquette Quarry, where the Brandon Amphitheater now stands. This was a recent big surprise. Most of the things I'm illustrating today, I'm trying to focus on things that were donated to the museum. But this is one I found myself with a club that I was entertaining from Alabama, the Alabama Paleontological Society, back in March. And we found this big tooth from a giant shark. And of course, my colleague, my shark expert colleague over here is going to criticize me for using the old genus name. Boo. And, not to leave the little invertebrate animals out, this is a recent discovery by, who found this? I may have found this one too, if I've not credited anyone. These things called thorny oysters. That's a large modern one on the left, and a recent discovery of a little tiny one. It was so delicate, as you can tell, it's only a fraction of an inch in diameter. So cleaning the surface of it to get around the delicate little spines was quite a chore. And even I couldn't even complete the task. The spines were so fragile. Why do you think an oyster or any animal living on the seafloor has to be spiny? Okay. And that's usually the case. It's certainly the case with it's part of the case with sea urchins. When we think about a characteristic of an organism or some kind of adaptation it has to accomplish something, we tend to only think of the one thing, but actually things evolve for multiple purposes. They serve, any part of your body serves multiple purposes. If that's the case, well, it's the same case with animals, the same case with plants. So what else in addition? Okay, all right. With respect to these guys, they are using those thorns to also help anchor themselves to the seafloor. It helps them sort of grab the seafloor, even though these spines aren't mobile like they are in sea urchins. They can move them in sea urchins, but these guys' spines, they're fixed. They can also, so in a soft seafloor, the spines enter the sediment and sort of help anchor them. But they can also cement the spines to sort of glue them to objects on the seafloor if they're hard objects. So the thorny oysters, like these guys, they can anchor themselves in soft sediment, but they can also cement themselves to hard objects using those spines. Now on to the next epoch. So we've moved from the orange area in central Mississippi, now we're moving into that yellow zone, working our way to the oldest part of Mississippi in the northeastern corner. These shark teeth are from Meridian, Mississippi. How many of you heard of the shark tooth beds beneath the Walmart and Lowe's, or the Lowe's Plaza in Meridian, Mississippi, just behind the old Red Hot truck stop? Okay, yeah, you've heard of have you ever collected there? Coach, you've collected there? Yeah, okay, good. Yeah, some of the club members have collected there in years past. It's all overgrown and underneath that plaza now, but there are a few streams in the area that yield fossils of this age, the Eocene epoch. And here are two different types of sand tiger teeth from the deposits there in Meridian, Mississippi, from behind the old Red Hot truck stop. And since I knew my colleague, again, over there at the table, was going to be here, I decided to show off some of these nice mollusks that he and his student friend from the University of Alabama found on one of their recent expeditions. Very nice mouse shell there in the center. Aren't they beautifully preserved? You don't get this kind of preservation everywhere. Very seldom in this part of Mississippi. It's just awesome preservation. Flanking it is an animal called a limpet, another type of mollusk. There to the left of it, and then to the right of it, a type of bonnet shell, or dove shell on the right. Sometimes I can't remember the common names. Yeah, those are really cool finds. And here is a fossil that's been a recent subject in an abstract presented this year at the Mississippi Academy of Sciences, which took place in March after our annual Fossil Roadshow at the Science Museum. One of my colleagues described the occurrence of these trace fossils. These are burrows. Essentially, so a burrow is hollow, but this is the backfill that enters a burrow after an animal has been mining. The animal can backfill the burrow himself with his activity, or his digging activity, or the burrow can remain open. Some animals, like ghost shrimp, can maintain an open burrow for a long time. When the ghost shrimp dies, say if he's eaten, something comes along and pulls him out of his hole and eats him, well then the hole itself can be just naturally backfilled or naturally fill in. We think these particular burrows are not naturally backfilled. We think there's an animal whose digging activity and eating activity is drawing these organisms into the hole, at least the fishes. These burrows, as they're defined as the Lepidopteron, we give names to trace fossils, not just to animals, but to the traces they leave behind. And we give separate names to the traces they leave behind because we don't always know the exact identity of the animal. So this burrow, this fossil burrow here, which we call Lepidopteron, is characterized by the occurrence of fish bones in the burrow. But it doesn't end there. We've speculated as to, are these the consumed remains of fishes that the animal that actually lived in the burrow ate? Or could these be fishes, little fishes, living in the burrows? Both instances occur today. We know that there's animals on the seafloor today that they're eating fishes and then digesting them, and then maybe vomiting or whatever their contents out into the burrow, or pooping. Can you say poop, Atisha?
Yeah.
Defecating. I guess I was concerned that not all the young ones may know what I meant by defecate. Surely they do. Poop is so much more fun. And there are fishes that live in burrows today. And there's this whole field of study about animals living in the dwellings made by other animals. So perhaps some other animal made the burrow and the fishes are taking up in there. We see this in the modern gopher tortoise that lives in South Mississippi. The gopher tortoise makes this burrow that becomes a home to so many other different species, like the endangered indigo snake. And there's many other snakes, and there's somewhat 300 plus different species that live in vertebrate species documented living in gopher tortoise burrows. Chris is not paying attention to whether I'm accurate or not. He's doing something else.
300 seems like a lot, but yeah, that seems right.
It's way up there. Of course, that includes invertebrate species too. And there's a whole field of study about that. It's called inquilinism, if you want to Google it. But yeah, so we're not sure exactly what's going on with these burrows, but having excavated some of these similar burrows in other deposits, I think these may be actual animals, actual fishes living in burrows. And why do I know that? Based upon these stones. These paired stones are from the ear bones of fishes. Are some of you familiar with these little stones that are located inside fishes they use for hearing and balance? The ear stones, also known as fish otoliths. We actually have them too, but they're not as well developed as they are in many fishes. In fishes, they're actively using, we use other parts of our ear, but the fishes are using these ear stones for hearing and balance. They have 3 of these stones, and one of them is generally more hyper-developed or larger than the others. And in this case, in this particular burrow, this is a case where a burrow, these otoliths you see here, from a different formation, not from the Moody's branch, as the burrows on the right are. But these stones are from a younger deposit, but we think they're the same type of phenomenon. The thing with this Bay Springs otoliths, those backfilled burrows did not preserve, in the sense that they did not remain intact like the ones from Yazoo County. So those burrows, they cemented, the backfill cemented, and so now you have all the shells and the fish bones trapped in the cement. However, on the other hand, on the left-hand side, the Bay Springs burrows, they were loose. They did not stay together. But I was able to scrape up all the contents and share them with a colleague at the University of Louisiana Monroe, who is an expert in fossil ear stones of fishes. And so we started looking at these bones and inspecting them very closely. And we noticed that for every left-hand bone or left-hand otolith, there was a right-hand component, and they were in really good shape. So we decided that these were fishes living in burrows. And we think they're related to these Lepidopteron from Yazoo County. And there's very few people working around the world on these objects, and we have not shown them to a trace fossil expert yet. So we could just say that I'm wildly speculating until we can actually get somebody to confer with us, to confer with somebody that might either refute what we're seeing here or agree with us. But we think we have a good lead on the origins of these burrows now. They're really kind of fascinating. And here's a close-up of one of these otoliths, so you can see the front and the back side. But on when I say front and back, I guess there's left and right. On the bottom shot, you see this tadpole-like pollywog-looking structure. That's very characteristic of the ear stones. Most fishes have that sort of shape, but it's the shape of the tadpole that it varies from species to species. Now, if you look at that scale there, that's 4 to 6. You've got 20 millimeters size there. That's one of the biggest otoliths I've ever seen in the fossil record, and that's from a marine drum. In fact, all the otoliths on the right are from a marine drum, but notice how much smaller they are. And a drum is a type of fish. Here's yet another type of burrow, if you're not tired of burrows yet. This is a type of burrow that we're pretty much absolutely certain made by a crustacean. This one's also from Yazoo County, from the same area as those on the right, but it's obviously made by a different organism because it's differently composed. We don't see any fish bones or concentrations of fish bones in these burrows. It's usually just shells and sandy sediment. And here's something that we're going to guess at. Now, obviously, I've had the benefit of holding this in my hand, cleaning it when I found it, and holding it in my hand, and having studied it. So I am at an advantage, but how do you guys perceive it? Just based upon a picture. And I think I only have one angle of it. Yeah, I just have the one shot. So it's about an inch long, and it's over 2 centimeters, or something about an inch long, and it's got these scale-like structures on it. I didn't expect anybody to get this right. I mean, I wouldn't be able to tell what it was from a picture if I wasn't already familiar with the animal. Even if I was familiar with it, just a picture might be difficult. Well, if you guessed at it all day, there's probably no way you could guess at it because it's an unfamiliar animal by today's standards, and they're living today. They're called barnacles. Well, I mean, we know barnacles, but this particular type of barnacle is called the scapelliform barnacles. And there are 2 types of these barnacles. There's another group called the gooseneck barnacles, and these are very similar to the gooseneck barnacles. This is a scapelliform barnacle, and they have like acorn barnacles that you see attached to logs and piers on the modern coastline, often in large aggregations. They have these mini plates on them, but instead of the plates being directly attached to the surface of the wood or whatever it's attached to, they have a neck that the plates are suspended on. And that neck itself has many, many tiny scale-like plates along the length of it. And that's what you're seeing right there. You're seeing these scaly neck to this scalpelliform barnacle. And here's some of the plates that compose the barnacle itself. Well, the head of the barnacle, as it were, the business end. And they come in many different shapes. Most of them are paired right and left. Those were associated, but I didn't have all the plates on that specimen. They didn't all preserve. Now, moving on to the next time interval, we're moving into the brown zone between the yellow and the green there, into the Paleocene epoch. And this is a very recent find that I made in Ripley, Mississippi. Well, I made with my colleague Kendall Bullock. We were together when this was found. He showed me the locality. That's the son Ryan over there, who's pretending that I'm not even talking. No, it's okay. He's watching. And he recognizes it because his dad shared a picture of it after I found it. We were very excited about this. So why would I get excited about that lump of whatever? And again, I've had the advantage of holding it in my hand. I have more of a three-dimensional sense of it. These pictures just can't really convey the shapes of some of these more bizarre things. Does anybody want to throw a guess out there? And it truly is guesswork. I never would have guessed it. You know, even if I'd worked on these fish, the modern, they're fishes. I'm going to give that away. But even if I worked on these fishes, they're living today, I worked on them all my life, I may not know much about their skeleton. Say if I studied their ecology or their biology, I may not know much about their skeleton. And I have shown bones of animals to some of my biologist colleagues at the museum in the past, and they don't really recognize them because they're used to looking at flesh on those bones. So just because you know the outward structure of the animal doesn't mean you always know what's going on in the inside. So this critter right here is called a chimera. It's a type of fish. It's not related to sharks, and it's not related to bony fishes. It's sort of somewhere in between. It's related to rather ancient sharks. It's a descendant of an ancient group that is not as populous as the bony fishes and the sharks and rays are today. But here it is in place in the mouth. So that's the left jaw of this thing. Oh, I could have approached it from that side. So that jaw right there is this jaw right here. You can kind of turn that thing around like that. The point is there. That's the same point you see on the fossil on the right-hand side of the fossil. And this is what a chimera looks like. Rather weird looking animals. Very strange. There are several different species today. Probably at least 10 different species living today. They're not commonly encountered. I think they're mostly very offshore and in deeper water. There are ratfishes, elephant sharks. They're not true sharks, but there's one species called the elephant shark.
Of which shores?
Indian Ocean. Yeah, I'm sure we have them in the Gulf of Mexico. But yeah, they live in modern oceans. Wherever we find shark teeth in the fossil record, we generally find remains of ratfish. Most people don't recognize them. Who's found shark tooth before? Okay, I'm sure wherever you were finding shark teeth, you probably saw chimera fossils and didn't recognize them. The likelihood is very great, but that's what they look like. So now you know. They don't preserve as easily as shark tooth, or individual shark teeth preserve. And this is an example of the critter that this jawbone belongs to. This critter called Ischiotis.
Is their chemical composition about the same as a shark tooth?
That's a good question. That's a whole Pandora's box. In the sense that this animal has no teeth per se. It has a pad, a chewing pad. And I'll point out the pad to you. Instead of individual teeth, it has this pad or plate right here. Here's one pad. And the pad doesn't erupt like an individual tooth does. It just sort of wears over time, and the structure of the pad goes deep inside the bone. And so as the animal gets bigger and bigger, not only does the dental material of the pad erode, just like our teeth erode as we chew and with age, but the bone is eroding away too. That the pad is embedded in. And also near Ripley, Ryan's dad, Kendall, we collected a bunch of these turret shells. These turret shells here, turritellas, compose a bed in northeastern Mississippi called the Turritella bed. I got the time periods wrong. Sorry about that. Why didn't somebody bring that to my attention? I didn't change the time periods on that. Yeah, so it's not 34 to 28 million years old. Apparently I didn't finish the slideshow. So for the past 2.5 weeks, I'm trying to apologize for this. Somewhere in between there, I had to stop and do this slideshow because I forgot to do it before I left for my field work. And so I went home one day and put it together, and obviously I didn't correct those time intervals because I was copying and pasting. But yeah, we're dealing with 64 million years ago, 65 million years ago for these deposits outside of Ripley, which that's within the Paleocene epoch. And so these turritella shells form a discrete interval in time, pretty confined with respect to its age. And they seem to have been concentrated in an environment for which they were particularly very successful. They were very abundant in this type of environment. And also in these same beds, we find these little oysters. These are recent finds from the same Highway 15 cut that they're working on and doing the bypass around Ripley. And these are called nose oysters. It's kind of weird. This is a shark tooth from a site near Cotton Plant, Mississippi, from a same interval in time. Slightly older, maybe 66 to 65 million years old. Also recent finds. Now, staying in the Paleocene, about 64, 65 million years old, and also in the Ripley area, we find these little crustacean remains. These are from ghost shrimp. And you can put a picture of what a ghost shrimp looks like. But these are animals that live in burrows. And their skeleton is actually quite soft. They have a soft exoskeleton. Most crustaceans today have hard skeletons unless they're molting. They molt like spiders molt. Snakes molt. There are many different unrelated organisms that molt periodically. When crustaceans molt, their skeleton becomes soft. These ghost shrimp, their skeleton is soft all the time, and it's protected inside a burrow in the ground, except for their palms, their chelae, and their fingers on their chelae. They're very hard, and they need to be hard all the time so that they can cut things and they can prey upon things. And also in the same interval of time, about 64 million years ago, are these fossils from the Tombigbee River just across the Mississippi line in Alabama. These little solitary corals. Also recent discoveries. A lot of these discoveries relate to field research we've been doing over the last 2 years along Highway 15, the Tombigbee River Basin, and a couple of other places around Mississippi and Alabama where we're looking for evidence. We're primarily looking for evidence for an asteroid impact 66 million years ago that killed the non-avian dinosaurs. But we have a team that is national, actually it's an international team, and includes my volunteers over here, and they're actually doing research in other areas as well. But we're looking at what's going on just after this asteroid impact, but also what's going on before it, and comparing what happened after the cataclysm. This was a global cataclysm.
Are you finding evidence to support what you think?
Oh yeah. In fact, most of the team that convenes every summer is looking directly at the direct evidence for this impact. And part of the team is just looking at how the animals recovered. after the cataclysm. But yeah, we have evidence. I've given a slideshow about this before, but we won't have much time to talk about it now. In fact, we won't have any time, because we want to talk about the recent Cretaceous fossil acquisitions there. I was with the University of Southern Mississippi in March, and we recovered this ammonite from near Ripley, Mississippi at another location. We're doing a lot of work in Northeast Mississippi these days, and have since 2010. But this is a mold, an internal mold with some of the shell preserved of these animals distant related to the modern chambered nautilus, which you see in cross-section here. And nautili and ammonites are types of cephalopods. And cephalopods often have chambered shells. The shelled ones often have chambers in their shell. And the chambers are filled with certain amounts of gas and liquid, and the animal can metabolically change the ratio of the gas to the liquid just by thinking about it. And just like we metabolically can control many aspects of our organs and our organ systems. But this is a feat that allows them to change their vertical position in the water column. So if they increase the gas to liquid ratio in their chambers of their shell, they can rise, and vice versa. If they decrease that, they can sink. But they also swim very effectively with their tentacles. Well, actually with their siphons and their arms, they're swimming. They have these siphons that can jet propulse them. And here is a recent donation from the University of Mississippi of a type of gastropod that's very rare, and we seldom find it whole. And this object is from Blue Springs, from the late Mr. John Young's place, right across from Toyota. A spectacular specimen of this species, and it's a type of giant turret shell. And another recent donation from Northeast Mississippi is this dinosaur tooth. A tooth from an armored type of dinosaur. These are very, very rare. And the gentleman presented this at one of my public lectures in Columbus, Mississippi, just less than a couple of months ago. Now that was a really neat find. So that tooth is just shy of exactly an inch long.
How on earth, when you see a tooth, do you realize from what it came?
So the way I respond to that, that's it's a standard question with a standard response that I've developed early on, because it's truly no different from me walking into the guy that works on my car, and just by making a sound and telling the mechanic where the sound comes from. If I'm a good mimic, he'll know right away. But I'm not a good mimic of what my car sounds like, but he still knows. He's not seen a picture of it. He's not even been under the hood, but he knows exactly what's wrong with my car if I make a certain sound. So it's no more magical than that.
Takes a lot of knowledge.
Yeah, it does. And again, it's just truly no different from anybody specializing in anything, or just knowing something, not even being a degreed specialist in it, but just knowing a lot about it.
Perfect answer.
So there's no specifics, it's just noticeable.
Oh yeah, there's lots of specifics. Don't tell an auto mechanic there's not specifics about it.
But they have to know.
They know it's noticeable, they don't know.
Oh yeah, I'm sorry, I see what you mean. Yeah, I apologize. Yeah, exactly. That's all we know about it, because it's just one part of the animal. Yeah, absolutely. But there's just enough in this case that we know it belongs to a notosaur. And we've got a handful of notosaur remains now, but we can't get anybody to work on them because they're too scrappy. People, they want more elements. The experts want more elements. They want to be able to, they want more information, in other words. Good point. And here's a recent donation from the Birmingham Paleontological Society on one of their trips, led by my colleagues over here to the right. They took the BPS out to a site in Pontotoc, and one of their members found this neat little tooth. We don't see this guy a whole lot. We happen upon it occasionally, and it's sort of a long-lived genus in the Cretaceous period. This group belongs to a group of fishes called the saurodontids. Disregard the shell on the far left until I finish talking about saurodontids. Bad transition. The saurodontids, we had several different species of the saurodontids. It was a dominant fish group during the Cretaceous period of the medium to the large fishes. And they were rather elongate, rather eel-like in their form. And this particular tooth belongs to Saurocephalus, the guy in the middle.
Has
At
it
least.
been polished to make it look pretty?
No, in this case, it's,
Actually, that pretty.
yeah.
Wow.
And I guess pretty is a word. It's also pretty sharp. The shell on the left was recently donated by an entomologist, or a former entomologist at the MSU Entomology Museum there in Starkville. I mean, he's still an entomologist. I don't know if he's employed with the university anymore or not. But Mr. Joe McGowan, he is a local artist, very famous for his abstract representations of Mississippi species. In fact, it was his experiences with insects early on in life, I think, that helped form his abstract interpretations of them, and they are fabulous, and they are wild and just crazy representations. And it's beautiful artwork. But Joe found this scallop shell. Now, we find lots of scallop shells in certain deposits, but this is a this particular scallop, Lirioclamies with field eye, is very rare to find complete. And so this was a very special find. So this thing is about 1.5 inches wide and almost 3 inches long. And it's a good size scallop. And it's beautiful. I love scallops. They're one of my favorite fossils. Aesthetically, they're really cool. But they're also cool biologically. This would be in the category of those scallops that could swim. A lot of scallops can swim and rest on the seafloor and then just jet off. And I think we're getting close to the end of the slideshow. We're going to close with a couple of slides having to do, I think, mostly with sharks. I was actually going to ask you what this is, and now I've already given it away, but they're atypical shark teeth. These teeth are from a group of sharks, shell-crushing sharks, called the tygodonts. And this one's from Tychodus mortoni, or Morton's tygodont shark. And these can be found in the Cretaceous belt that runs through northeastern Mississippi. And as you can tell, very atypical for a shark.
Am I not reading it correctly, or do these seem to point to the back, or they just crush it?
There is a back and front orientation to them. And at the bottom, so the one in the lower left, that indentation in the bottom of that one in the lower left, that is the back. Yeah.
George,
Yeah.
he's got some here.
Oh.
You see some-
My colleagues over there have some tygodont shark teeth over there so you can see what they look like up close. And actually, that was my last slide. I want to thank all my donors and volunteers, including the guy who I didn't credit in the slideshow for his discovery of the tapir fossil. I still can't squeeze it out of my head. It's been a long summer, and I just finished a week with summer campers.
We'll think of it tonight.
Yeah, I'll think of it tonight. And they are truly too numerous to list here. They are integral to the assisting the Museum of Natural Sciences' ongoing efforts of documenting Mississippi's biodiversity, both living and extinct. And I'd be glad to entertain any questions. And thank you guys for having me.